Today's episode is going to be a lot more of a filler episode from the last two that we did, because the last episode ended with the photon epoch, which started at about 10 seconds and ended at 380,000 years after the Big Bang. And I mean, that's a pretty huge gap, especially considering how we've been taking it piece by piece in the last few episodes. So I thought we would start from there and kind of go out past the photon epoch into the first couple millions of years. I thought it would be like an interesting way to structure this episode. So I just wanted to let you guys know that before we jump into it. There is one part towards the end of this episode that I thought was super interesting that I think you guys will hopefully really like. So yeah, let's just jump into this episode. So I think one important thing to note here is at this point in cosmic time, the universe is radiation dominant. And so at about 50,000 years after the Big Bang, the energy density of matter exceeded both the energy density of radiation and the vacuum energy density. So basically matter becomes the dominant force of the universe. Matter dominance lasted until about 4 to 5 billion years ago when dark energy began to dominate the universe, and continues to today, which is what it's believed. It's kind of like a newer idea, but I actually didn't know that. I still thought we were matter dominant. I didn't know that dark energy is what dominates the universe today. So that was pretty interesting to me to find out. Now, where the photon epoch ended is where recombination began, which is where the photons which compose the cosmic microwave background radiation were scattered. That's basically the reason why we have that today. At this epoch, charged electrons and protons first became bound to form electronically neutral hydrogen atoms. Before this point, all electrons were free to scatter the universe, but after recombination, all electrons and protons actually start forming atoms. Now, at the same time that recombination starts, at about 380,000 years, that's also where the dark ages of the universe start. It's a time between recombination and the formation of the first stars, and it lasted from about 380,000 years to 200 million years. So now the gaps of time are getting really huge. With the creation of hydrogen and helium, light is allowed to travel freely for the first time, but wouldn't light up the universe for possibly hundreds of millions of years. It ended with the fusing of the existing hydrogen atoms into more helium, making the first stars at about 200 million years after the Big Bang and lighting up the universe. So at this point, for the dark ages, the time between recombination and the first stars being made, it's literally just darkness. That's why it's called the dark ages. I mean, we have like helium and hydrogen atoms that are making it possible for light to move. It's still not enough to light up anything, so it's still darkness. And around this time, which is pretty crazy to me too, is where we call the Habitable Epoch, and it lasted from about 10 to 17 million years. The Dark Ages span a period during which the temperature of cosmic background radiation cooled down from about 4,000 Kelvin to about 60 Kelvin. When the temperature dropped down to 373 Kelvin, the possibility of liquid water became allowed for about 6.6 million years until the temperature reached 273 Kelvin, when liquid water became impossible again. This is what I think was really interesting at this point. There was speculation in this period of time, which is called the Habitable Epoch, that primitive life, also called biogenesis or the origin of life, might in principle have appeared during this window. This theoretical life might have been able to live on a rocky planet made habitable from the heat source provided by the cosmic microwave background radiation. So what it thinks is that there was a possibility for life here, like even if it's cellular life, like how it's believed that we started with science. And it was able to last because of the cosmic background radiation, which was able to make the planets habitable for these things to live on. And because there was, liquid water, because of the temperature, it was a possibility for 6.6 million years. I mean, that's a lot of time to also, start creating life too. So it's crazy that could be like the first instance of life that we could have had. I don't know, it just really makes you think about how small we are as people too. Not just people, but just as life itself. I don't know, I really thought that was really interesting. And this episode basically ends with the end of the Dark Ages, going into the creation of the first stars. And the first stars were just hydrogen atoms being made with more helium to make the first stars. And that was what lit up the universe. And from there on, I mean, we go into structure formation, which goes into the galaxies and just all these huge things that make up the universe today. And that kind of leads us into more modern day. And I think that once we finish talking about that and all the stuff that happened, we get to present day. From there on, we can actually talk about the far future and what, with the Big Bang Theory, we think the universe will end. And there are a lot of different ways. I think there are 3 big ways that they think that it might happen. I think the most prevalent one is heat death, and they all get pretty fucking scary. So that's going to be kind of an interesting one to talk about. Obviously, that's like way far past all of our lives, but it's still interesting to think about the universe itself, the thing that we live in today that we always thought for the longest time was just infinite, to actually possibly have a beginning and then also have an end. It's pretty crazy to think about. But in the next one, we won't be into, darkness and it being, the universe just being dark for millions of years. This one is actually more of like, the formations of the stars and then the galaxies. And I feel like that one will be probably a longer episode than this one. This one was definitely shorter than the other ones. But, I hope it was still good, and I hope it still worked out. So, thank you guys for listening, and I'll see you next time when we talk about structure formation.